So now in the previous class we have studied about all the types of aromaticity and all the types of aromatic hydrocarbons and the rules for assigning the aromaticity and aromatic hydrocarbons. Again I have given some of the examples and in the syllabus they have mentioned some of the examples. For an example, we have taken the benzene as an example, furan as an example, pyridine as an example, and 10 aniline as an example, which is the main intention is given in the syllabus is to check whether these compounds are really aromatic in nature or not by using the statement, by using the rules called as Huckles rules, and also it is by using the one of the rules, that is aromaticity rules. There are four rules. I have told if initially I have told if you referred once you will get better to understand the aromatic nature that I am explaining here. There are four types. There are four compounds in which we are going to arise a question, and in which you are going to study in detail what actually the aromatic hydrocarbons are, and what is the rules for aromaticity, and what is the fundamental aspects related to what aromatic and aromaticity. Now we'll be moving on with the rest compounds called as benzene, pyridine, furan, as well as and the fourth one is called as aniline. Now we'll be dealing with the first one called as to check whether this benzene, the given benzene is really aromatic hydrocarbon, is presence of whether this is really aromatic hydrocarbon or not really aromatic hydrocarbon ಐತಿ ಅಲ್ಲ check ಮಾಡಬೇಕು. And then we have another example that is called as pyridine, right? Then we have another example that is called as furan, and the last but not least, that is called as 10-aniline. This is one of the four compounds. These are the four compounds in which we have to prove whether these are really aromatic hydrocarbons or not by using the one of the method that is called as Huckles rules. Huckles rules na use ಮಾಡ್ಕೊಂಡು we have to what we have to show whether these are complete aromatic, which does they possess aromatic nature or not. Now we will begin with one by one. Now let us start with the what benzene. Start ಮಾಡೋಣ. What is benzene? Benzene is nothing but what is benzene? Benzene is what? Which bears our benzene structures and which is a truly aromatic in nature. And to explain the aromaticity of a benzene, in other words, they have explain aromaticity of a benzene, explain aromaticity of a pyridine, explain aromaticity of a furan, explain aromaticity of a 10 with Huckles rule. ಈ ತರ ಕ್ವಶನ್ಸ್ ರೇಸ್ ಮಾಡಬಹುದು. One of the best example, and to start with benzene. There are four conditions to check whether this benzene, this given compound, is really aromatic in nature or not. There are four rules. Again, I will write here for the sake of understanding. And the very first one rules is called as the compound should be cyclic in nature. The compound should be cyclic in nature. Does benzene possesses any cyclic in nature? If it possesses, then there is a 4.1% that it might belongs to the aromatic compound. And then there is a rule second that is called as which exhibit sp2 hybridization with the planar structure. If it exhibits these two rules, then there is a chance of 80% chance that it benzene undergoes aromaticity. And there is a third rule that is called as what? That is called as delocalization of pi electrons. If this compound containing pi electrons that has to be delocalized in the outer shell, that is called as benzene ಒಳಗ delocalization electrons ಅದು ಅಂದ್ರೆ that is called as it nearly belongs to the aromaticity nature. Then there is a fourth rule that is called as Huckles rule. If it satisfies Huckles rule, then it might be called as a complete aromatic hydrocarbon, and that is completely aromatic in nature. It is completely aromatic in nature. See, these are the four rules. You have to check whether this benzene given compound is truly aromatic in nature or not. If any one of them, either rule 1, rule 2, rule 3, or rule 4, any one of them dissatisfies, then the given compound should not be aromatic in nature. Remember all the rules R1, R2, R3, R4. If any one of them, again I will repeat, if any one of them is dissatisfies the rules of a given compound, then it is really not aromatic hydrocarbon. It is not aromatic in nature. Now let us begin with the benzene. Now let us draw the structure of benzene, and then we'll explain all the characteristics of all the rules. Then we'll apply all the rules of our benzene, and we'll give one of the structure for benzene. Now let us start with the benzene. Let us start with the benzene. Now we know the structure of benzene. What is the structure of benzene? See, this is a structure of benzene that we all know, right? There is a presence of all types of bonds, single bonds and double bonds, and there is a presence of one more ring that is called as ring. This is a ring, and this is the structure of benzene. I think you know the structure of benzene is this much. I think this is the exact structure of a benzene. Right, now we'll move on to the applicity of Huckles rule and all the rule 1, rule 2, rule 1, rule 2, rule 3 and rule 4. If you apply these 4 rules for this given compound to check whether this compound is really aromatic in nature or not. Now we'll be moving with the rule 1. That must be, this compound must undergo cyclic nature. Cyclic nature as the benzene is containing cyclic in nature. The benzene is completely cyclic. That's why it possesses one of the ring or one of the bond in its inertial. That is called as the one first rule is satisfies for this benzene. Benzene, which is completely cyclic in nature. This is one of the best rule and which is applicable for the benzene. Benzene is one rule applied. That is called as this compound is completely cyclic in nature. That's why it contains only one ring. That is called as one double bond. Now we'll move on to the next rule that is called as which exhibit a planar hybridization, which exhibit a sp2 planar hybridization. Planar hybridization or planar structure. Yes, it is what? Yes, it is planar in nature. There is no double bonds with the other compounds mixed in with it. There is no other bonds which is completely inapparated with, right? There is any other bonds which is like this. No, there is no other bonds which is attached to one of the benzene. There is a single benzene that we can say, that we can saw. That's why it is sp2 hybridization with the planar structure. sp2 hybridization with the planar structure. Then there is a rule 3 that is called as delocalization of a pi electrons in its outer shell. Where is the presence of delocalization? Presence of what? Presence of pi electrons with its delocalization electrons. Then here in this case of a benzene, there is a complete delocalization of electrons takes place. How it will be explained little bit more. Now there is a fourth rule that is called as Huckles rule. That is which must satisfy. Remember, this benzene satisfies one rule, second rule, and the third rule. Now we'll move on to the fourth rule, which are applicable for what? Benzene. Now we are applying the fourth rule for benzene. That is, which exhibit 4n plus 2 into of 5 electrons. Into of 5 electrons. Now there is a small little bit calculation for this benzene to verify whether this benzene is really aromatic in nature or not. Now I will draw and I will calculate. It is not so important, it's not so complicated, and as we do the mathematics daily, it is just a simple calculation to give the final touch for benzene. Now I will move with the little bit and very small and very tiny calculation for benzene. Very tiny calculation for benzene, right? Now I will move to the very tiny calculation. Now we have Huckles rule. What Huckles rule states that in the previous class I have already told you what Huckles rule states that, which is completely of what? Which multiple of this much, right? Now we can see the presence of rings in the benzene. There is only presence of one ring, right? That's why in the place of n we have to place 1. What is n? N is not only, it is not fixed at, it is not fixed as 1. We have to say that n is any kind of integer that is multiplied of 2, 4, 6, 8, or in some other cases periodic it is 1, 2, 3, or 4. That it must be an integer. It should not be a rational. It should not be a rational. It should not be a irrational. It should be a integer, right? It should be what? It should be what? It should be a complete integer. Now, in the case of benzene, we have placed only one ring. There is only one bond in the case of benzene. That is called as n. In that n, we have to substitute in this n we have to substitute the amount of there is a presence of ring in this one. There is a presence of only one ring. That's why I will substitute one here and then multiplied by pi electrons. Multiplied by pi electrons. Then what will becomes? It will just becomes 6 pi of electrons. Then again it satisfies the Huckles rule, and it really satisfies the Huckles rule. Again to tell it again, it what the benzene again satisfies the fourth rule for aromaticity of a benzene. Benzene first rule ಅನ್ನ satisfy ಮಾಡ್ತು. That is called as, that's why it is called as what? That's why it is called as what? That's why it is called as aromatic in nature. In the other manner, in the other results, we can say, we can write that benzene is also called as, benzene is also in result we have to write benzene is a aromatic hydrocarbon, and it is aromatic hydrocarbon. It is what? It is aromatic hydrocarbon, and then it satisfies the principle of or then it satisfies the principle of, then it satisfies the principle of, then it satisfies the principle of, then it satisfies the principle of aromaticity, right? Aromaticity na principle and follow ಮಾಡ್ತಾ. That's why it is a really a aromatic hydrocarbon, right? Benzene ಅನ್ನೋದು ಏನಾಗ್ತೈತ್ರಿ? Benzene ಅನ್ನೋದು ಕಂಪ್ಲೀಟ್ ಆಗಿ aromatic hydrocarbons. Like this we have to explain for the furan, pyridine and tannidine. These are the only four compounds that they have given for syllabus. Now we'll be moving on with the what? Furan.